means that when I take a look at 15, I'm going to start with my x to the third. Because it was a negative in front, I keep it negative x to the third. I put plus 15x, and then I put plus 3. That is descending order. I looked at it's a third degree, so instead of writing third degree, I write cubic. And then I have 3 terms. Terms are always separated by addition and subtraction. Even up here, I have a subtraction and an addition, so I have 3 terms, so it is a trinomial. Okay? So you are looking at once you've combined your like terms, and this next one, this is also a trinomial because you're adding those like terms together. So you should be adding the x terms together in this one as you are looking. Third plus 4x to the third. Both x to the third, so if I'm adding those, 9 plus 4 gives me 13. I'm going to say x to the third. 3 plus 7? 10. Done. That's it. Okay. As we look at 33, it says that you need to, the fence around the quadrilateral shaped pasture is 3a to the third, okay, plus 15a plus 9 units long. What is the length of the fourth side of the fence? So we know that the perimeter happens to be 3a to the second plus 15a plus 9. We are subtracting, if we know, these 3 sides. So if I'm going around here, I want to add those like terms, and I have a squared, right, because this is my a squared here. So I have this a squared minus 7. I have plus 10a minus 2 and plus 5a. I want to add my like terms. So if I'm adding those sides, my new length, because I don't know this one, I'm going to subtract. So I have 1a squared. I'm adding 10a and 5a. That gives me 15a. So I have another plus 15a. And negative 7 and negative 2 is going to give me a negative 9. Now, we are subtracting that whole thing in purple. So when you subtract that, that means it was a positive 1a squared. It's now going to be negative. This is going to be negative 15a and plus 9a. So when I actually subtract, I change subtraction to adding the opposite. 3 minus 1 gives me 2a squared. 15 minus 15 is 0 a's plus 18. That's how they got that answer on that last question. Okay? The key thing for most of these is just really be careful with that. When you have that negative, it's going to change everything to plus a negative 5d to the third minus 3d plus 4, and then you're adding your like terms as you take a look at those. Okay? So, if you factoring. So it says if you remember distributive property, so what I want you to put down for distributive property is we start with something like this, 4 times x plus 3. And if you had that, what are we looking at when we use the distributive property? We are looking at taking 4 times x, right? So 4x, plus then we are taking 4 times 3, which gives us 12. So part of your assignment is going to be to use the distributive property and get this answer. But the other part of your assignment is going to be to factor. So when you factor this, you are going to start with this problem and you're going to get this for an answer. You're going to say, what do they have in common? These two things, what do they have in common? They have a 4. So when we divide them both by 4, we're left with 4 times parenthesis x plus 3. So when you multiply, okay, when you multiply, you're moving this way. You're distributing. But I'm also going to ask you to factor today. So we're going to be looking at doing both of those, looking at what they have in common. So again, I might ask you to use the distributive property and give you this problem, negative 8x, and then we have it times x squared minus x plus 4. If we are looking at doing the distributive property, when I take negative x times x squared, I'm going to get a negative 8x to the third power. Because exponent rules say that when I multiply, I add my exponents here. And then I'm taking negative times a negative. That would give me a positive 8. X times x would give me x squared. X to the first, x to the first. And now I'm going to take negative 8 times 4, negative 4 minus 32. And I'm just going to have an x. If I was asking you to work your way backwards, okay, I would say, look at this problem, and the directions would give you this is the problem, and it would say factor. When it says factor, you want to say, well, what do all of these have in common? Well, they all have an x, and the smallest power of x is x to the first. So if I'm factoring, I am trying to always look for what's called your greatest common factor first, right? They all had an x in it. What else do they all have that's divisible or goes into every single term?
Oh, 8.
Bigger, 8, right? So what if you factored out 8x and not negative 8? That would be okay, right? I would take that as an answer. And you factored out 8x. Well, if I divide this by 8x, what are we left with? Negative 1x to the second. What if I divide this one by 8x? I'm going to be left with plus 1x. And if I divide the last one by 8x, I should be left with negative 4. Okay? Is this almost the same as what we started with in our original problem? The only thing different is we factored out an 8x, they had a negative 8x, right? So a lot of times we won't necessarily need to factor out that negative, but that's what you're going to be doing in today's lesson. So when they look at this, this is called the factored form. So as you're looking at your notes, this is when we think about something being factored, how we're going to write it with that term in front times all of the rest of those. Expanded form or using the distributive property. So what you're asked to do is to write all 3 of these in expanded form. Remember, exponent rules apply. So when we start this one, we're going to have negative 9, x to the 3rd times x to the 4th gives us x to the 7th, not 12. Okay? We're taking negative x times negative 2. That's like a negative 1 in front of that, right? So that gives us a plus 2. X to the 3rd and x to the 3rd would give us x to the 6th. We are taking a look at, as you are looking at this next one, as you are multiplying, we should be multiplying a negative x cubed times positive 7. We're on H2.
I was wrong.
You were. I know. I was trying to see what page you were on. Negative 7x to the 3rd. So when we are looking at this, we would say that this is a 7th degree, right? If we're looking at today's 7th degree, because we don't have a name for that. And this would be a trinomial, right? So just to practice that vocabulary when you're thinking about it. So please do the next one, if you would. Is this next one going to be a trinomial or binomial? It's going to be a binomial, right? Why do I know it's a binomial? Because there is only one subtraction sign in here. And as we distribute, what am I going to get for that first one as I distribute? Maya, what should I have? Yes. Well, when as I get that next one, when I distribute expanded form, I'm going to have yep. So this would be a 5th degree, right? If I was looking at that 5th degree binomial. Okay. If you haven't done the last one, please try that one right now. 1, right? We are looking at 4f to the 3rd plus 5f squared. This would be a cubic, right? 3rd degree, cubic trinomial, right? So if we're thinking about those names, we just call it a polynomial. If it is like a bunch of more than 3, we call it a polynomial with the rest this way, okay? So factor of a polynomial means to rewrite it in factored form. It's the reverse of our multiplication process. When factoring a monomial from a polynomial, the first step is to find the greatest common factor of those polynomial terms. The greatest common factor of each term and then write it in factored form. So when you take a look, you always want to look at the number. When you're looking at the number, what you're looking at for the number is what's the largest number that divides into all of them, right? So when you look at your greatest common factor for a number, you look at 5, 25, and 45, the number that divides into all. Okay, so when you look at that number, it's the largest number, so you always want the largest number, that would divide into all of them. Well, 5, 25, and 5, the largest number that divides into all the numbers is going to be 5 in this case. When you look at the greatest common factor for the variable, okay, so some people sometimes get confused. When you look at the number, it's the biggest number that divides into all, but when you look at the variable, it is the smallest power that they all have in common. So here you're looking at the smallest power, which in our case, that they all have in common, X to the first, X to the second, and X to the third. Our smallest power would be X or X to the first, however you'd like to write that, okay? I would take it as X or X to the first. So they kind of show this example, and they say, okay, here's what is the greatest common factor. So part of your homework just says, what is it? You can see that they wrote these out in prime factors. Do you need to do that for each one of them? I think most of you can just kind of, if you have your multiplication facts, what do they have in common? Pi goes into all of them, and then X. But so also says you might want to look at a factor tree, and so you look at this next one down, and they say, oh, how do you factor this one? Again, for many of you, I think you can look at the 4, the 24, and 8, and go, okay, does 4 go into 24 and 8? Yes, so my greatest common factor is going to be the number 4. Okay, 2 times 2 or 4. And then the smallest exponent power is X. So what you are then doing is you are trying to take each of these terms individually, and you're like dividing them by 4x. So that's how you get the 4x out in front. If we divide this, 4x to the 5th divided by 4x, we are subtracting our exponents when we divide. That's how they got x to the 4th. Here, if you divide by 4x, you're going to get minus 6. X to the 3rd over x gives us x to the 2nd. And here, if you divide by 4x, the x's simplify to be 1, and you get 2. So it says when you are simplifying, check your work. So the nice thing about this unit, kind of like before when you solve equations, you can work backwards, multiply this factored form out, and it should give you your original problem. And if you start with a factored form, you should be able to get, so you can work backwards and forwards. So the distributive property, multiply it out to get your answer. Expanded form, you should get that solution as you look at it. So we are going to be asked to factor these. So the first thing, rewrite in factored form. That means factored form means I need a parenthesis. I need something times the parenthesis. So the first thing I'm going to look for is what is my greatest common factor of 9, 15, and 12. Number that goes into all should be 3. I'm looking at the smallest power of the variable, which should be x to the 2nd, because they all have x's. Sometimes they don't all have a variable. So I'm going to put 3x to the 2nd. This is my greatest common factor. Now, sometimes instead of writing this probably like this, is what I might do is go, okay, I want to divide this by 3x squared. 9 divided by 3 gives me 3. X to the 6th divided by x squared is x to the 4th. Remember, we're subtracting our exponent rules when we divide. I'm going to divide this one by 3x squared. 15 divided by 3, 5. X to the 4th over x squared. X to the 2nd. I'm going to divide the last one by 3x squared. 4. And I'm done. So this one, when you start it out, some people like to get rid of that negative. So I'm going to have you, as you are looking at this one, pick your greatest common factor. It's going to be negative, and the largest number that divides into all of them should be 6. Smallest variable power is y to the 2nd. How many terms do you have to have inside here? 3. You started with 3, got to end with 3 inside here. So try it.
1 y to the 2nd.
1 y to the 2nd. Freddie, what am I going to have for that next one when I divide?
3y.
Okay. Positive plus 3y or minus 3y?
Positive.
Plus 3y. If I'm looking at the next one, Caleb, I'm going to have
2.
plus 2
Plus
minus
2.
2.
Plus 2.
Plus 2. Okay. The y's canceled. Negative divided by negative half. So it says, is there only one correct answer to these problems? There is not just one. And the main reason is, what if you, in this one, what if instead of factoring out 3x squared, you would have factored out negative 3x squared? Or here, if you would have factored out, instead of negative 6y squared, you factored out 6y squared. Does that change the answer? Yeah, the negatives, the positives. So that greatest common factor, if one of them is positive or negative, that's really what changes it. So they're very similar in those answers, but you will sometimes have just one. So that last problem that you're going to be taking a look at is asking you to find, so So it's a helicopter pad, so some of these story problem ones that we will look at, which is a circle inside the square, is visible from the air. What is the area of the region outside the circle but inside the square? So, write your answer in factored form. Okay, so first up, what does it mean? This part says leave your answer in terms of pi. That means when we simplify everything, we do not want to multiply by pi on our calculator. The reason is it's going to be irrational and it gets to be really long, and it's an approximation. This way we get an exact answer and not rounded. So, if I'm trying to find this orange region, I need to take the what? Area of the square and subtract the area of the what? Circle. So the area of the square, if it's a square, each side is the same, we do what? 6x times, wait, not the perimeter, the area.
Oh.
6x, this is 6x also, so that's like 6x times 6x, right?
Oh, yeah.
Or 36x squared. Okay. We're going to subtract our circle. Area of a circle, the formula is radius squared times pi. So our radius is 3x. We have to square that times pi. When we square it, 3 squared is 9. X squared pi. So at this point, this is kind of our answer, except we did not do factored form, right? So if you finished it like this on a quiz, you're kind of right. So what do they both have in common? They both have y at what? What's one thing they have in common? Both these terms. It's divisible by 3. Bigger?
9.
9. So we want to go with the biggest number. It's going to make it easier. So we're going to factor out our 9. Henry, anything else they have in common besides 9? Those two terms? They both have x to the second or x squared. So I'm going to factor out a 9x squared. What you're thinking in your head when you look at this is, okay, I'm going to take 36x squared divided by 9x squared. Joel, when I do that, I end up with 36 divided by 9 gives us 4. X squared divided by x squared is just 4, right? Minus, I'm going to divide the next one as I'm taking a look at that. Brooklyn, when I divide this next one by 9x squared, I'm going to be left with pi. This is factored form. Our answer is in terms of pi. We are done. 9x squared times 4 minus pi. Look at that, okay? Your homework is on page 495.